Don't even stress it. All right, let's have a look at this question over here really quickly. Okay, so we know that if we want to make G the subject of the formula, exactly, Mandisa, they won't be mad forever. It's true. All right, we know that if we want to make G the subject of the formula, first thing I'm going to get rid of is this negative C. I'm going to take negative C over to the other side, and I'm going to get F plus C is equal to mv squared over GR. Now, the thing I want is in the denominator. So in order to get rid of that, I'm going to multiply by GR on both sides. Okay, but now I have to multiply this whole thing by GR times GR. And I don't like that this thing is in my way, so I'm going to make it a little bit smaller and move it over there. Okay, so times GR on both sides. Both of those things will cancel. So I'm going to end up with GR times F plus C is equal to mv squared. And then that really helps me because I want G on its own. I'm going to divide by everything else that is not G. So I'm going to divide this side by R times F plus C. And whatever I do to the left-hand side, I'm going to do to the right-hand side as well. R times F plus C. All right, R times F plus C will cancel and R times F plus C will cancel. Therefore, G will be equal to mv squared over R times F plus C. All right, and that's the final answer we're looking for. Welcome to Maths Live this afternoon, everybody. I hope everybody's doing great. If you are joining us for the very first time, welcome, welcome, welcome. It's so great to have you. I think you're joining us at the very end of our algebraic journey. We're going to be doing something a little different next term. We're going to get started on trigonometry. I just want to double check with everybody. Hands, give me a thumbs up in the chat if you've started trigonometry at school. Give me thumbs down if you have not. Where are we looking when it comes to trigonometry at our school? Do you guys want to fill me in? Have we started it yet? Anyone? Or rather than that, tell me, what have you guys started at school? Okay, Morangi has started. Great. Mandisa says only next term. Okay, same with our kids. We're only going to start it next term. So we haven't quite started it just yet. Okay. All right, but technically we should start it in week 9, which is coming up in just a little bit now. All right, and that is going to be kind of sort of week 2, but because we're a little bit behind at Maths Live, because I only have one lesson with you guys, I should actually be done with trigonometry. So what we're going to do over the holiday, if you are willing to join us, and if you're happy to join us, is we're going to be going through trigonometry over the holidays. So then the next 3 weeks during the holidays, we're going to be doing exactly that. And if you do miss it because you're on holiday somewhere, like I know some of us, if I go to my grandmother's house, there's definitely no Wi-Fi, so I'm not going to be able to join. Then lucky for you guys, we will be recording and then you'll be able to get those recordings and watch them. But if you haven't started it at school yet, you're in luck because then you can do it at school. And then I'm going to tell you guys right now, I'm really, really good at helping you guys understand trigonometry. It's a really tricky subject, but if we do it right, we're going to be really okay. So guys, stick with me and we're going to do it and everybody's going to love trigonometry by the time we get to the end. All right. Okay, that being said, today's topic is not actually trigonometry. It's not literal equations. Today, we're going to be talking about exponential equations. Now, I'm going to remind you guys that in the other lessons, when we did these kinds of questions, where we had 2 to the power of x plus 2 times 8 to the power of x plus 1, we couldn't compare exponents unless we had what? Who can remind me? What did we need to have in order to compare exponents? Yeah, I heard that. Was that you, Mandisa? Yes, beautiful. We need to have like bases. So the only way we're going to be able to have like bases is if we change 8 to a product of its primes, which would then mean we'd have to change 8 to 2 to the power of 3, or 2 cubed. So we'd get 2 to the power of x plus 2 times 2 to the power of 3 times x plus 1. And that's how we work. We needed to make sure that we had the same base in order for us to compare exponents. So when we talk about exponential equations, that's exactly what we mean. Now, I'm going to make a very easy statement, and I know you guys are all going to be able to tell me what the answer is. If I say to you guys, I have 2 to the power of x is equal to 2 to the power of 3. If 2 to the power of something is equal to 2 to the power of 3, what does that tell me that x is equal to? What does x need to be equal to here? In order for this statement to be true, because remember, an equal sign means that the statements on both sides are true. What does x need to equal in order for both of these sides to be true? X must equal? Correct, Cat. Cat has put it in the chat. X must equal 3, 100%. X must equal 3, because then my statement should read 2 to the power of 3 is equal to 2 to the power of 3. All right, and that's true, because that's going to give us 8, and that's going to give us 8. 8 is equal to 8. It's quite simple. We're not really doing anything revolutionary here, right? So if I say to you guys now, I've got 2 to the power of x is equal to 4. What do we know that x must equal? X must equal what? 2, correct. X must equal 2. But rather than us just saying that x must equal 2, we can add an extra step. We can say 2 to the power of x is equal to, and I know that I can rewrite 4 as 2 to the power of 2, 2 squared. That then tells me that x must equal 2. So what I'm actually getting at here is if we have the same base, then we have the same exponent. Okay. So if my bases are equal, then my exponents are equal. Just like here. This is 2, that is 2, therefore that and that must be equal to each other. And that's basically how exponential equations work. Now, let's look at this example that ma'am's written over here. Now, I know that 2 to the power of x is equal to, how else can I write 32, guys? As what?
The power of 5.
Correct, 2 to the power of 5. Well done, Malisa. There. I can rewrite this as 2 to the power of 5. And as soon as I see that my bases are the same, what I can actually do is I can drop them. I can just drop my bases, and I can therefore make my exponents equal. Therefore, x is equal to 5. All right, so we're actually going to drop the bases to make the exponents equal to each other. All right, let's practice this. Let's practice this a little bit. All right. Here's questions 1 and question 2, right? You guys can pop the answers to these in the chat. They're not very difficult at the moment. We're starting off a little bit easy. I've been nice over here. I've already given you the same base. That therefore tells us x is equal to what?
2. Yes?
2. Yeah, x is equal to 2. 5 to the power of x is equal to 5 to the power of 2. That means that x is equal to 2. We can just drop our bases. Drop the bases, x is equal to 2. Now, in question 2, what can we do with 27? I know 3 to the power of x is equal to. How else can we write 27?
3 to the power of 3. 3 cubed.
Correct, 3 to the power of 3. 3 cubed. Correct. Now this becomes 3 cubed. And now that I have the same base, I can drop my bases. Therefore, x is equal to 3. All right, so nothing difficult there, but let's step it up a notch. Okay, let's look at questions 3 and 4. All right, let's see if we can solve for number 3. Pop your answer. If you have an answer for me for x, for number 3, pop your answer in the chat. Tell me x is equal to, tell me what it is.
Ma'am, for number 3.
Yes, for number 3.
Is x equal to 4?
Correct. How did you get there, my darling? Explain that to us.
I said 9 to the power of 2 is 81. And then, no, ma'am, let me not lie, I just guessed.
Yes, okay. All right. So, Madisa, let's go back to that example that ma'am was saying, that if we have 3 to the power of x plus 2 times 9 to the power of 2. The only way we can really compare the exponents of these two things is if we have the same base, right? But how else can we write 9? We can write 9 as?
Power of 2.
Correct, as 3 to the power of 2. So that's exactly what I'm going to do. I'm going to write 3 to the power of x is equal to, now 9 is 3 to the power of 2, but 9 was already raised to 2. So this then becomes 3 squared all to the power of 2, because that 2 was already there. Now, whenever I see a bracket and an exponent, what am I going to do with these two exponents here?
You're going to multiply.
We're going to multiply them, correct? So those two will multiply each other. So I'm then going to get 3 to the power of x is equal to 3 to the power of 4. And there we go. Therefore, x is equal to, these two can drop our bases. X is equal to 4. All right, I want us to do the exact same thing with 4, but now this time, we're not going to be changing the right-hand side. We're going to be changing the left-hand side. Can we do that?
Ma'am, I think I got the answer.
Oh, absolutely, Sia. Tell me, what answer did you get?
My answer is x is equals to 4.
Okay, tell us how you got there. How did you get there?
So I said even 4x is equals to 2 to the power of 8. So the 4 I changed it to 2x and to 2 to the power of x bracket 2.
Correct. So I'm going to write 2 to the power of 2 bracket x, because the x is the thing on the outside, yes? And that is
Yes.
equal to 2 to the power of 8. Good. And then our next move?
And then it's going to be 2 to the power of 2x is equals to 2 to the power of 8.
That's it, is equal to 2 to the power of 8. And now I can drop my bases. Excellent work. Good. Therefore?
And then 2x divided by 2 and 8 divided by 2.
Correct. Divide by 2 on both sides. Good. Therefore, x is equal to 4. Well done. That's it. 100%. Therefore, x is equal to 4. Absolutely. Beautiful method. 100% what I was looking for. That's it, Sia. Good work. All right. I'm going to do a quick check-in with everybody. Thumbs up. Does everybody understand where both Mandisa and Sia are getting these answers? Thumbs down if you want me to do another example. Let me know. I see Morangi. I see your thumbs up there. Excellent.
Thumbs up.
Beautiful. I heard that. Everyone else, how are we doing on these questions? Thank you, Kat. Just turn my phone on silent. All right. Thank you, Desmarie. All right. Okay, let's continue. They're going to get a little bit more challenging as we go, but I want us to see if we can figure out numbers 5 and number 6. All right. Now, use what we know about mathematics to answer questions 5 and question 6. All right. What can we... Number 5. All right. Madisa's already got this one for us. Okay, tell us, what are we going to do at number 5?
Ma'am, I'm literally holding my calculator while doing this. I think that's why I'm so quick with getting the answers.
But I'm not sure how we would do this in a calculator, unless your calculator does have a shift solve exponential equations function. Does it?
No, ma'am. I just guessed because I know a number to the power of 0 will always give you 1.
Right. Madisa, that's not a guess, my darling. That's the correct answer.
Oh.
That is the correct answer. You're not guessing. You're giving us the correct answer. We know that anything to the power of 0 is
1.
Is 1, correct. So all we're going to do is we're going to choose the base on this side to be something that we already have on this side to the power of 0, right? So I can rewrite this as 4 to the power of x is equal to, what am I going to choose as my base to the power of 0 here? I want it to look like the left-hand side. Something to the power of 0. What is that something there?
4.
4, exactly, 4. Because I know that as soon as I have the same bases, I can just cancel. Therefore, x is equal to 0. So you're giving me all the right steps. It's not a guess, my darling. You know exactly what you're doing. All right. Good job. Well done. Okay. All right. Let's have a look at number 6. I'm also going to show you number 7. For those of you who might already know what to do, go ahead. All right, there's number 6 and number 7. Tell me what we're thinking of doing. Number 6 is a little bit tricky. I'll give you guys that. But
Ma'am?
think about how we would tackle this one.
For number 6, right?
Yes.
Is x3? I'm just guessing. Now I'm guessing.
No,
Or not.
x is not. It's
Ma'am, is the answer -3?
who said that?
Is
Is it you, Kat? Yes,
ma'am.
you are 100% correct, but you're going to have to tell me how you got there. Okay.
Okay, so first off, I started by changing 8 into an exponential number, which I got
You got
2
1 over 2
exponent
to
3.
the exponent 3. Excellent. Good.
So I apply the laws of indices on the fraction because the laws of I think it's law number 7, right? Where
You don't need to
when
remember which law number it is as long as we use the correct law. Okay. So what do we
yes,
know?
so since 2x is a denominator and it's so I can take it to be a numerator, but then I have to change the sign of the exponent. So it's going to be 2.
Absolutely. It's going to be 2 to the
Going
power of
negative x. So
Ah.
since I have the same basis, so I'm going to equate my exponent. So I'm going to have negative x equals to 3. But then I'm looking for x, not negative x. So I'm going to divide by -1.
Oh, my goodness. I've never been so impressed. Like, I mean, flowers for Cat everywhere. Just mwah, beautiful. Therefore, x is equal to negative the Cat. You deserve a medal. I feel like we can just promote you to grade 11. You're done here. You are finished here.
Yeah,
That's it. I'm kidding, my darling, but that was so beautifully done. Just mwah, hands down, best explanation I've ever seen. Well done, Kat. Amazing
Thank-
work. Sure.
Thanks.
Are we all understanding where Kat is coming from? Let's think about it this way. Let's do it the opposite way. If I say to you guys that I've got 3 to the power of -4, and I told you that I wanted this thing with a positive exponent, you would all put it over 1, and then you'd flip these two things. You would flip them, and you would get 1 over 3 to the power 4. Now, what Kat has done is she's taken the 1 over, and she's just done this rule in reverse. So she's now taken this thing to the top and taken that one to the bottom. And now that it's positive at the bottom, when I take it to the top, the exponent is just going to change to a negative. So she's done the opposite of the indices rule. Well done. Okay, well done. It's actually the opposite of the negative exponent rule, but yes, we'll take it. Kat, just brilliant stuff. I just want to double check with everybody. Are we all understanding what Kat has done here? Are we all okay with what she's done? Because I can guarantee you guys, I can 125% guarantee you a question like this will come out in one of your papers. This one and that one. They love these questions. Okay, and by they, I mean me, because I also test my boys and my girls on these kinds of questions. Okay, so they always ask questions like this. So make sure that we're understanding where we're going with this kind of question. It's very, very important. All right. Okay, let's have a look at number 7 and number 8, because these are going to be a little bit trickier. Okay, but look at question number 8. It looks exactly like the one that Kat just helped us with, just with a little extra twist, with a bit of a twist. Okay, let's look at number 7. Yes. I didn't quite catch that, my darling. Say that again.
Ma'am, I'm saying for number 7 is x equal to 2.
Yes, but you must explain the process to us.
Ma'am, you can explain it.
Okay, remember, Mandisa, I can't go into a test and say I guessed Therefore, x equals 2. You're not going to get any marks. Okay, so we need to understand the mathematical method behind it. Let me give you guys another example before we do this one. If I said to you guys that I've got 2x is equal to 6, how would we solve for x here, my darling?
Then you divide by 2.
We would divide both sides by 2, right? We would divide that side by 2. Therefore, x is equal to 3, right? So I know that in this particular question that we have over here, the thing with the x is that part. That's the part with the x. Now, everything else that doesn't have x needs to go. I don't need it. Everything else that doesn't have an x needs to go. So I've got 2 times the thing with the x. How do I get rid of that 2? That's multiplied to the thing with the x.
Ma'am, do not move it to the other side.
How? It's multiplied to 5 to the x.
Oh, so you have to divide. Oh, wait.
Good. I would divide the side by 2. And what I do on the left-hand side, I must do on the right-hand side. Good. So those 2 will cancel. Now I've got 5 to the power of x is equal to 50 divided by 2.
25.
That's it, 25. And now I know I can change 25. 5 to the power of x is equal to?
5 to the power of 2.
That's it. And my bases are the same, therefore we can drop them. Therefore, x is equal to 2. And there we go. You are 100% correct. You must show us method, though. Okay.
So,
Yeah,
ma'am.
Yes. Oh, I'm hearing 2 ma'ams. Can I quickly take Sia's question, Kat, and then I'll come back? All right.
Okay.
Sia, what's up?
Ma'am, I got another step on how to get the answer.
Okay. Okay, let me know. How did you do it? What did you do?
So then, the 50, I put it in exponential form.
100%. You can actually shift factor it, right? So what did your
Yes.
calculator say?
It
We
said
got
2
the
times
power
5
2
squared.
times 5 to the power of x is equal to 2 times 5 squared.
5
And
squared.
that makes perfect mathematical sense, right? Because then this side and that side will both divide by 2. And there, do you see how we're going to end up with the same answer? See, you're not wrong at all. 100% that is a mathematical process that you can 100% use. All right.
Okay, thank you.
In fact, we don't even have to divide by 2. You can just leave it like that. I don't think any teacher would have a problem with you just saying, we know that if we want these 2 things to look exactly the same, x must equal 2. There's nothing wrong with that at all. 100%. Beautiful method. Good stuff. All right. Kat, what's up?
I wanted to say the same thing
The
because
same thing. Yes. Mhm. Tell me, my darling.
Oh, like I wanted to say because like I also used this one, yeah. I didn't divide by 2. I just saw, okay, there's 2 this side and that side, so they'll disappear. Then I have 5 as the exponential numbers, so I just took x down and then equated it to
That's
2.
absolutely correct. Yes, 100%. That is 100% correct, my darling. Both you and Sia are spot on. The mathematics is correct. Okay, well done. Well done, both of you, for spotting that. All right, let us do questions 8 and 9. Ooh, now number 9 is a little bit difficult, but I'm pretty sure we all know how to solve question 8. Can I give everybody 2 seconds? Not 2 seconds, 2 minutes. Ooh, 2 seconds is asking a lot. Let's take 2 seconds. Oh my goodness. 2 minutes to answer question 8. And then if you can, try and answer question 9. Trust me, it's not that difficult. We're just employing the same things that we use there. I'm going to give everybody 5 minutes to answer questions 8 and 9. Pop your favorite emoji in the chat when you're ready. I'm going to pop my emoji of the day today because genuinely, guys, I'm not feeling 100%. All right. Questions 8 and 9. Pop your answer pop your favorite emoji in the chat when you're ready, and we can check back in the next few. All right, take it away, guys.
Ma'am,
Yes.
when you're substituting x over there, does it apply to the numerator and the denominator?
In question 8.
Yes.
Yes, it does, but I'm going to tell you, Sia, that's not going to help you. Think about how else we would write just the 1/4 part before we incorporate x. Okay. Think of just the 1/4 part and think about the way that Kat solved the other question first. Okay. Just work with 1/4 and then incorporate x when you're ready. Okay.
Okay.
All right. I hope that helped. If it didn't, I'm sorry. Kat and Mandisa, you guys are way too fast. Sure. Everybody else, you've got 2 minutes left. Hello, Amanda. It's great to see you. I hope you're doing well, my darling. All right, let's have a look at these two questions over here. All right, if anybody wants to venture an answer on how they did number 8, I'm more than happy to take your suggestions. But if you're a bit stuck, then I need you to guys really listen in, because what we're going to be doing is using the same mathematical tools that we did in the previous questions. Okay. All right. So let's talk about 1/4. I know that 1/4 is the same as 1/. I can rewrite 4 as 2 squared. And then I know that I can take the 2 squared over to the top. And I know that my exponent, if I flip this, then will turn negative. It's positive down here. When I take it to the top, it's going to become negative. So I'm going to get in brackets over here, 2 to the power of -2 to the power of x is equal to, and I can then rewrite 32 as 2 to the power of 5. All right, so I then know I have a bracket and an exponent. I can multiply those two. So I'm going to get 2 to the power of negative 2x is equal to 2 to the power of 5. Okay, and now that my bases are the same, I can drop my bases and I can make my exponents equal to each other. That tells me that negative 2x is equal to 5. And guys, if we've done the mathematics correct, we should not be afraid of fractions in our answer. Okay, sometimes that's what it needs. So just because we don't have a nice, well-rounded answer, it doesn't mean that your answer is wrong. Okay, if you've done the mathematics correct, it should come out correct. Negative 2, divide both sides by negative 2. Cancel, cancel. Therefore, x is equal to negative 5 over 2. That's the final answer. No worries, Amanda, we're just happy to have you, my darling. Okay. Yes, yeah, see, I told you. You got this, you got this. All right, then in question 9, we're going to do the exact same thing with 3 to the power of x. We're going to bring that up to the top. So what I'm going to have is 3 to the power of x minus 2 is equal to 3 to the power of, if I take that to the top, it's going to give me negative x. Right, and then my bases are just going to get dropped. I'm going to get x minus 2 is equal to negative x. And then we're just going to move things around. That thing with a negative x goes over to the other side. The negative 2 goes over to the other side. Then we're going to get x, and then the negative x comes over and becomes plus x is equal to negative 2 goes over and becomes positive 2. X plus x is 2x plus is equal to 2. And then we're going to divide both sides by 2, divide by 2, cancel, cancel. Therefore, x is equal to 1. All right, and there's the answer we get for question 9. Okay, tell me, how did we do, guys? For number 8 and number 9, did we get both right? Did you get one right? Tell me how we did in the chat so I know how best to help you guys.
Both
How did we
right.
do? Both right. Well done, Sia. I love it. Desmarie, Morangi, how did we do? Moleboheng, I can see, my darling, you're having a bit of connection issues, which is worrying me because I need you to be like present. But remember, we are recording, so if you don't catch the lesson, then it's okay. Well done, Kat. Palisa, how did we do? Yes, well done, Palisa. Excellent. There's someone named El Mpapuli. I'm pretty sure I'm pronouncing your name instead of your surname. Your surname instead of your name. So please tell me who you are so we can change it for you and we can call you by your actual name. Okay. But I'm so glad many of us are getting this correct. Well done, guys. All right. Okay. All right. How about we have a teeny little bit of a brain break today? Can we do that? I know. It's like, oh, what? Teacher Coco, we're going to have a brain break? Okay. Yeah. All right. I want to teach you guys something. It takes a little bit of logic to get the idea of the story. I need a volunteer. Hands up. Anybody who wants to play with me? Anybody want to play with me? Oh, I heard a me. Who is that? Who is that? Was that you, Mandisa?
No, ma'am.
Was that not you? Oh, anybody? It's a pretty simple game, I promise. It's nothing too hectic. We're just going to do this. We're going to take the two numbers, the four numbers, 1, 2, 3, and 4. Kat, yay. All right, let's go. All right, Kat, do you want to unmute for me, my darling? All right, here's the objective, Kat. The objective of this game is to be the first one amongst you and me to reach the number 30. Okay. And I'm going to let you go first. You can only choose the numbers 1, 2, 3, and 4. And we're going to be adding the numbers together. Yes, absolutely, Amanda. We're going to be adding the numbers together. And as we add the numbers, whoever makes it to 30 first wins. Okay, got me?
Okay,
All right.
I got
But
you.
Kat, do you want to start us off? Pick a number.
I'll take 2.
Okay, 2, good. All right, so I'm going to then add 3. So we're at 5. Okay, pick another number.
4.
You can only pick one of these. Okay, 4. Plus 4, that means we're at 9. I'm going to pick plus 2. And now we're at 11. Pick another number.
4. I'll take 4 again.
Plus 4, good. We're sitting at 15. Are we sitting at 15?
Yes.
Cool. All right. So it doesn't really matter what I do. You're going to win. I'm going to pick +1. Oh, no, not really. I'm going to pick +1. So we're sitting at 16. Okay, you go next. Let me
I'll
see if
take
I can.
4.
+4.
Take 4.
That puts us at 20.
20.
20. All right. I'm going to pick +2. What's your next number? That's at 22. What are you going to pick?
I'll take 20. I'll take 3. I'll take 3.
Ah, 3. And she's figured it out. +3 will get us to 25. And from this point, it doesn't matter which number I pick. I pick 1. That'll make 26. So Palisa's going to make it to 30 before me. So what number are you going to pick?
I'll take 4.
+4. And there we go. So Palisa makes it to 30. So not Palisa, Kat. Sorry. So Kat wins. Now, Kat, I just want to ask before we continue, have you figured out the trick?
Ah,
Don't tell me if you know the trick, but tell me if you figured it out.
no, I don't know. I
No.
did.
Okay, all right, that's fine. So I'm going to play with Amanda, and I want to see if Amanda can know why I can already tell who wins before we get to the end. Amanda, are you there?
Yes, ma'am.
All right, do you want to go first? Go for it.
Yeah.
Mhm.
I was still going to 30.
We're going to 30, yes.
Okay, I'll pick 3.
3, okay. I will pick 4, and that puts us at 7.
Okay. I'll pick 4 also.
+4 again, that takes us to 11. And I will also pick 4. That will take me to 15.
I'll pick 3.
+3, that takes us to 18. And I will pick 2, and that takes us to 20. Pick a number.
I'll pick 2.
+2, that's going to take us to 22. I'm going to pick 3, and that takes us to 25.
Okay.
And at this point, it doesn't matter which number you pick, I'm going to win.
Ma'am, 1.
I'll pick 1, but I'll pick 1.
+1, that gives
No.
26. And I'm just going to pick +4. Sia, have you figured it out yet?
Ah. Oh no. That's not fair.
Teacher Coco wins.
That's because you're a
Sia,
math.
do you think you figured it out?
I think I did, ma'am, because excuse.
Okay,
I
tell
did.
me why. Why do you think? How have you figured out the trick just yet?
I
I
did.
can see why. Oh.
I'm not sure who's talking. I think is it Kat or Mandisa or Amanda?
It's me.
Amanda, tell me, have you figured out the trick?
Not at all. I
Not
just
at all.
thought,
Oh,
I don't know.
Ma'am, I think I did, ne? Because okay, you are coming as the moment you guys hit 20. I don't know who added +2. Then it became 22. Then, like from there, you can see which number you can add to see who wins.
Okay, but what number are we trying to get to before we get to 30? Have you figured that part out?
26.
No?
Because I got to 26.
Not really. Okay. All right. I'm going to ask one more person to play with me. And this time I'm actually going to use a pattern. And I want to see who can figure it out. Anybody else want to play with me? Mandy said you want to play?
Yes, ma'am.
All right. Excellent. I'm going to let you pick first. And I'm going to show you guys that doesn't matter what Mandisa does, I'm going to win. Mandisa, pick a number.
1.
1. I'm going to pick 4. That takes us to 5. Pick another number.
2.
2. That will take us to 7. I pick 3. That takes us to 10. Keep going.
3.
3. That takes us to 13. I pick 2. That takes us to 15.
Ma'am, wait.
Keep going.
4.
Ma'am wants to be the first one
If
to
you
reach
pick
the
4,
15.
19. I'm going to pick 1. That takes us to 20.
You can't. Okay. 1.
1, that's 21. I'll pick 4. That takes us to 25. And at this point, it doesn't matter what you do, I've already
well.
won. Yeah? Okay. Sia, have you
3.
figured it out?
3, ma'am.
Have you figured it out, Mandisa?
3.
3. If you pick 3, that's 28. I'm just going to pick 2. That gives me 30, and therefore Teacher Coco wins. Okay.
Ma'am, you cheated.
Let's play one more time, Mandisa. Let's play one more time. You start
Okay.
first. Or do you want me to start first?
Ma'am, please start.
Okay,
Ma'am, does it
I
have
will
to be
start.
the
I will
first
pick
person
3.
to reach 15?
You pick one. Sia, put that thought in the chat so that Mandisa can see it. Mandisa, you're up. I chose 3. You pick a number.
I'm choosing 3 as well.
3. That takes us to 6. I pick 4. That takes us to 10. I've already won. Before we even continue, ma'am's already won.
Oh, wait. Let me think.
Pick a number.
1, ma'am.
1, that takes us to 11. I pick 4. That takes us to 15.
Yo.
I figured it out.
Sia's figured it out. Okay,
4, ma'am.
Sia, tell me what, Mandisa, because I'm going to tell you now, I've already won. Teacher Coco's already won. Tell me how, Sia, how does Teacher Coco win?
I think the first person to reach to 15 already knows that they won. Because like no matter what, if you reach 15 first, no matter what number you the other person puts, if you reach 15 first, you're gonna reach 30 first again.
Because 15 is half of 30.
Oh, well, not particularly. All right. So what I'm actually trying to do, guys, is I'm trying to reach the number 5. I just have to go up in increments of 5, right? Let's think about it. Because we are only using the numbers 1 through 4, the biggest combination I can get from these numbers is 4 and 1. So if we get to 25, it doesn't matter which number you pick. If you pick the biggest number, I can always just add 1 to get to 30. So my goal really is to make it to 25. If I say 25, it won't matter which number you say, I'm going to make it to 30.
Ma'am, can
Am
I
I
please
making
go through one more time, ma'am? Can I start?
Okay,
Wait, one
sure.
more time.
All right. Do you want me to go first or do you want to go
No, ma'am,
first?
can I go first? Let me go first.
Okay, go for it.
Let me start with 3.
3, I'm going to pick 2. That takes me to 5. If I pick 2, that takes me to 5. I've already won, by the way.
Never mind, I don't want to
Supposed
play
to
anymore.
start.
Okay, think about it, Mandisa. If I keep going up in increments of 5, because 4 is 1 less than 5, it doesn't matter which number you call, as long as I go from 5 to 10 to 15 to 20 to 25. If I make it to 25, whatever number you pick, I can add to make 30. So I just need to go up in increments of 5. So if we think about it, let's say, for instance, we want to make it all the way to 50. If I want to make it to 50, and I use numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, what increments are you working towards? If my biggest number is 9, what increments do you need to work in? In increments of?
9 and 1.
Yeah, of 10, right? Because if I say 9, you're going to say 1, that gives us 10. I say 9 again, that's 19. You say 1, that's 20. I say 9, 29, you say 1, that's 30. I say 9, 39, you say 1, that's 40. So from 40 onwards, it doesn't really matter which number I choose, you are going to win.
Oh, yeah, let me start again. Now I think I know how to.
Okay, are you seeing it? Are you seeing it now?
Yeah.
Okay, so let's use 1, 2, 3, and 4. Let's make it to 20. I'll start. Right. I'm going to pick 2. What number are you going to pick?
3.
Good. That gives us 5. I pick 1. What number do you pick?
4.
Sorry, if I pick 1, that takes us to 6. What number do you pick?
4.
Good. That takes us to 10. I pick 4. That's 14. What number do you pick? you made it to 5, you made it to 10. I'm at 14. What
One.
number must you pick? You must pick one, 15. So do you see, it doesn't matter which number I pick. I'm not going to make it to 20. You're going to win. Right? Because if I pick 4, that only brings me to 19. That frees you up to say 1, which then means you win. Okay, so the way you win, the objective of the game is to make sure that you are always making it to +1 of that number. So even if there were 10 numbers, if we use the numbers all the way between 1 and 10, if I start, let's say we're trying to make it to 50. If I start and I say 6, we're using the numbers 1 to 9. If I say 6, what number are you going to choose, Mandisa, in order for you to win the game?
4.
4, exactly. Because if we add 4, we're going to make it to 10. And then you just one-up me in increments of 10 until you win. Correct. There is an absolute pattern, Palisa, and that's what we're looking for. It is a pattern. All right. So this is just logical thinking. This is how they ask questions. I don't know how many of you guys have written the Maths Olympiad, but this is the kind of thinking that they're using in order for you to answer Math Olympiad question.
I've only done the English.
So yeah, there absolutely would be a way, because what they would do is they would realize that in order to get to 36, you need to work in increments. If we want to make it to 36, you would need to work in increments of 6. Therefore, they will tell you only have 5 numbers. That's what they would do. So already, if we're working towards 36, you only have 5 numbers, you have to do add to get to 6, and then to 12, and then to 18, and then to 24, and then to 30. So you're automatically going to win the game. All right. Am I making sense? Okay. This is the logical thinking part of mathematics. All right. I've wasted enough of the lesson. Let's continue. Some exponential equations don't require us to think outside the box. Okay. Question, and then we're going to step it up a little bit. Everybody, look at question 10. Take it away. Right. I'll give you guys two minutes to answer question 10. Yes, yeah, absolutely. You can take this game and play with your teacher. I'm sure your teachers understand how it works, but maybe show them that you can beat anybody in class. That would really impress them. Then you can show them, aha, I know where you got that. Okay. Play against the other students and see if they will get it. But I doubt you they will. One student, but most of them. Okay, I just want you guys to note that this is 2 times. This is 2 times 4. And I just need to double check with you guys. Does everybody remember when a number is sitting all by itself, it has an exponent of what?
1.
1, absolutely, it has an exponent of 1. And that's a very important thing that we need to remember in this particular question. Okay. Actually, let me just separate them a little, just so we don't make a mistake. Yeah, there we go. The top one.
Ma'am, is the answer for number 10 equals to -1?
Is it -1? All right, let's see. I want to see if you're actually correct. Okay. And we are going to run out of time. So I'm going to go with it, Sia. Let's see if you're actually correct. Okay, so we know that we need like bases everywhere. 4 is not a like base. 8 is not a like base, but we can change them to like bases. So I'm going to get 2 to the power of 1 times 2 squared all to the power of x minus 1 is equal to 2 cubed all to the power of -x. Right. And then we've got a bracket and an exponent, and over here we've got a bracket and an exponent, but we must distribute over there. So we're going to get 2 to the power of 1 times 2 to the power of 2x minus 2 is equal to 2 to the power of 3 times -x will give me -3x. Okay, I have like bases everywhere, so I'm going to drop all of my exponents now. Over here, I have like bases being multiplied. So normally I would keep the base. What would happen to my exponents? What would we do with my exponents over here, Sia?
We're gonna drop them. We're gonna use them to substitute for x.
Correct. But if I have two bases that are being multiplied, what do we do with the exponents?
We add them.
Ah, there we go. Balisa said it in the chat. We add them. So what I actually have up top here is 1 plus 2x minus 2 is equal to -3x. Okay, that's what I've got. So I'm going to take all the numbers over to the other side. I'm going to take 3x, bring it over to this side. See, and now your answer is looking a little questionable, my dude. And then the -2 will go over to the other side, and the 1 will go over to the other side. So we'll end up with 2x plus 3x is equal to -1 plus 2. Okay, 2x plus 3x will give me 5x is equal to -1 plus 2 is +1. Divide both sides by 5, divide by 5. And that those two will cancel. And that will then give me x is equal to 1/5. Okay, so I know that the reason why I brought it up is because it's very important that we remember that there's a 1 over there. Okay. Ah, the negative. Okay. All right. I see, because then that would have given us -1. Okay, makes perfect sense. I see you. Okay, we would still give you a mark for for continuous accuracy, but you would definitely lose 2 marks for method. Okay, which wouldn't be so great. We wouldn't want that. All right, okay, let's have a look at this last one. I want us to have a look at question 4 before we go, because it is a little bit tricky. Right, I want us to note that it doesn't really matter what we do over here. Oh, I'm lying. That's 4 times that. Okay, I need to get rid of that 4. How would I get rid of that 4 over there, guys? I've got 4 times 25 to the power of x3 is equal to 4. What would we do?
Divide on both sides.
Correct, we divide both sides by 4. Divide by 4, divide by 4. And those two will cancel. However, now I've got 25 to the power of x plus 3 is equal to 4 divided by 4 gave me 1.
1.
Okay, what do we do now?
Gonna be
What did they we can do with 1? How else can we rewrite 1?
power of 0.
Not as 0 as sum to the exponent 0. So this is 1 is gonna become,
1 to the
I've
power
got
of
25 to the power of x plus 3 is equal to, how else can we write 1?
1 to the power of 0.
What to the power of 0? What exactly do we want as the base?
5 to the power of 0.
Oh, but there's an easier number than 5. What is the base on this side already?
It's
1.
5.
The base on this side is 25, right? All I need is the same base. It doesn't matter that it's not a prime number, guys. It doesn't matter. I can just change 1 to 25 to the power of 0. Do I not have the same base on both sides? I
You
do.
do.
So I can just do that. I can cancel those two. Therefore, x plus 3 is equal to 0. So what is x then equal to?
-3.
Negative 3.
Absolutely, -3. Okay. All right, so we do need to remember these rules, guys. Do not forget these rules. And we're out of time